All right, as promised, dilation's moving into the coordinate plane. When it comes to the coordinate plane, we're really focused on distance as opposed to a triangle got twice as big, so all its sides are twice as big. Now we're going to look at an individual point. Like this might be the corner of a triangle, and I'm just giving you one point on the triangle because even if this is a triangle, or if it's a rectangle or a square or some kind of quadrilateral and you have to dilate it, it doesn't matter what the shape is, you're just looking at the individual corners, the vertices. So you're doing these problems one point at a time. If it's a triangle, you have to move 3 points. If it's a quadrilateral, you have to move 4 points. And then you do them all the same. It's just like 3 problems in one or 4 problems in one. So I'm just going to focus on one point, and then you'll do this same technique for all the corners of your shape. And the technique is you need to move this point away from the starting point, which I did not give you the starting point on here. So if you are not given the starting point, which you usually will be given the starting point, but if you're not, you just assume that it's the origin. So we're starting from the origin. And the scale factor, which is going to be represented as a K, is 2. That means we're moving farther away. Remember, if the scale factor is greater than 1, you're moving farther away from the starting point. If it's less than 1, like 3/4 or 1/2 or some fraction less than 1, then you're going to be shrinking and moving closer to the starting point. When you're moving farther away and you're starting from the origin, all you have to do is multiply these numbers by the scale factor. It's real easy. So your answer is going to be 4, -2. 2 times 2 and 2 times -1. You're done. The reason that works is this distance right here, whatever that is, you need to double that. All right, because we're going twice as far away. So if this distance is 8, then we need to go 16 away from our starting point. All right, hopefully that makes sense. Scale factor is 2, you're doubling your distance. The tricky part is this distance is a diagonal, so it's hard to tell what distance that is. You'd have to do Pythagorean theorem, and even then, where does that distance go from here? You know, it could go off in any direction. How do you know exactly what's straight? So instead of finding this exact length, we're going to find how far across and how far down. So how do you get from the starting point to A, going across and down, or down and across, it doesn't matter. Instead of going diagonally, going in straight directions. Well, you go 2 spaces over and 1 space down. So you're going over 2 and down 1, and those are the numbers we're going to double. So instead of going over 2 and down 1, scale factor of 2, we're going to double that and go over 4 and down 2. Over 4 and down 2 puts us right here at 4, -2. And that's our A prime. And now A prime is twice as far from the starting point as A is. And that's it. If you start off with, say, a 1/3 scale, now we're going to shrink. So let's put A way out here at 6, -3. So that distance to get from our starting point to 6, -3 was over 6 and down 3. And now we're going to do 1/3 of that. 1/3 of 6 is 2, and 1/3 of 3 is 1. So instead of going over 6 and down 3, we're going to go over 2 and down 1, and A prime will be at 2, -1. That's all there is to it, people. It's pretty straightforward. It's not too difficult. You're just multiplying the numbers, the coordinates that they give you by the scale factor, and whatever you get, that's your new coordinate. Technically, that was a -3, so this would be -1. Sorry about that. That's how you do it. And I didn't give you very many problems today because it's a Friday and this is something new. So in case you're confused on it, you don't have a chance to ask me questions. I don't want to overload you with problems. And also on the first problem in the do section, they want you to draw the graph. You don't have to draw the graph. You could just give me the coordinates of the corners of the picture. I think it's a quadrilateral they want you to draw. So just give me A, B, C, and D. Give me 4 coordinates, and then you don't have to worry about drawing anything. And you just type your answers in. You can do that for all the problems. Just type in the coordinates of the A primes, B primes, and you'll be good to go.